Hello, everybody. Welcome to day 2 of Advent of Code in Kotlin 2024. How is everybody? It is Monday, famously everybody's favorite cat's least favorite day. But, I'd like to imagine that, since it is a day where we did get a new puzzle, that's probably a good day. How is everyone doing? Did you manage to do today's puzzle? Everything smooth? Any unexpected challenges? Hello, everybody who's saying hi. Hello. Just like yesterday, we are live both on Twitch and on YouTube. So wherever you are, just say hello. Already getting some good info here from Maya. Unleashed the Brute. I assume this is in regards to part 2 of today's challenge. So that's going to be quite exciting. I'll be honest with you, not too much spoilers here in advance, but when I did today's challenge, at first I thought I could be very clever about part 2, and then I kind of ran into a dead end, and I was like, okay, instead what we're gonna do is we're gonna do the easier solution, the more straightforward one. We'll need the benchmarking today. We'll see if we even come up with a solution that requires benchmarking. We'll see if we can figure it out or where we end up with. Yeah. But yeah. Okay, so it was related to part 2. Okay. So by the way, I'm currently drinking out of this wonderful little New York themed mug. I do try to show off a little bit of my my mug collection every now and then, which of course this is very topical, because if you do follow our YouTube channel, you'll know that the latest episode of Talking Kotlin, which we recorded recently, we actually did record in New York. So there's a nice connection there. I will, in full disclosure, though, say that this cup is not from that trip to New York. Someone just thought it looked cute and decided they would just give it to me. So now I have a New York mug that came through an entirely different channel. The episode is still worth checking out, mug or not. So if you haven't listened to that yet, it's one of our interviews with Russell Wolf, who's done a lot of great things in the multi-platform sector. So make sure you check that out once we're done here. Brute force is the best force. Yeah, I mean, for these problems, certainly oftentimes it really does help. And luckily with Advent of Code, at least in the earlier days, it gets you pretty far. We all know that, as things go on, sometimes there are puzzles where you look at the challenge and you immediately think, okay, part 2 is just gonna make this number way bigger, so I'm gonna be in way more trouble if I do the naive solution that stacks 4 or 5 like loops inside each other. It can get very troublesome. Hello from Norfolk, Virginia. Wow, look at this. We're all the way on the all the way across the globe. Oh, I love this interpretation. My solutions are always fast, as in they are sloppily written and far from optimal, and they get me on the leaderboard fast. That's a good way of looking at it. Just, is that what they call goal-oriented programming? I'm not sure. The goal is just to get on the leaderboard, and we'll take any shortcut we can get to get there. Something like that. But of course, this is actually a great segue into my typical spiel, because as we'll see today, you can learn something in Advent of Code whether you go for the leaderboard or not. You can learn something about algorithms probably, but you can also just learn something about Kotlin and how you can write code that's expressive and nice. And that's the entire point of the campaign that we're running. Because we are running an entire campaign around Advent of Code 2024 in Kotlin again. We at JetBrains are super excited to be sponsors of Advent of Code this year again. So it's we're actually very delighted to be able to support an event like this that does help people engage with their critical thinking skills and their problem solving skills. That helps and that also helps them engage with Kotlin, of course. So our campaign this year, once again, consists of multiple different parts. First of all, we got the live streams. We got 12 of those. You know about these because you're watching me right now. If you want to make sure that you also don't forget to tune in for any of the future ones, make sure you hit those little notify me buttons to make sure that you don't miss any of them, including the ones that might be slightly earlier, like day 7, where we'll have it at 2 p.m. instead of 6 p.m. in my time zone. But I do still rewrite the solutions afterwards. Yeah, that's fair enough. And I think Johnny has quite a similar approach here. Yeah, you write a little bit of sloppy code that gives the result, and then for the rest of the day you try to come up with a nicer version. It's almost like red-green refactor, right? You just kind of try to first build something that works at all, and then you make it, well, you optimize it by whatever constraint is important to you, whether that's fast execution time or super easy to read, or, I don't know, scalable, extensible, has a plugin system. Who knows? I mean, there's many things that are happening, right? But of course, besides the Advent of Code live streams that we're doing, we're also doing something for folks like you in the chat who love to compete. We have a couple of leaderboards. Actually, we have 7 of them. And if you compete here, then you will have, if you're a top scorer or if you're part of some of the randomly drawn participants, you can win some exclusive Advent of Code in Kotlin swag, which is going to be very exciting because there is no other way to get those things. And in addition to this, even if you're not competing, there's also another way of getting that very exclusive swag and those goodies, which is by tagging your repository as AOC 2024 in Kotlin on GitHub and solving a couple of the puzzles, just 3 of them, using Kotlin, and that already makes you eligible. Someone else pointed this out in the stream yesterday, so I want to mention this here again as well. If you are competing for the top scores in the leaderboards, please be kind to all of your fellow competitors and don't use AI or some kind of LLM-based solutions to solve the puzzles. +1, we see a couple of other folks here who have set their own goals for Advent of Code, aiming to go to ON, so running it in linear time thanks to the tips from Kotlin's Slack. Quite exciting. Very nice. So yeah, I think overall for housekeeping, we have most things covered. Almost. I also just want to shout out once again that KotlinConf 2025 is still somewhere in the distant horizon, but it's still possible to get some tickets. And more importantly, if you have a topic that you feel very passionate about in the Kotlin multiverse, we have extended the call for speakers for 6 more days. So if you are if you're thinking about submitting, I would encourage you right after this stream, go and submit. Don't wait for the 6 days. This is already the extension. I can guarantee you there won't be another one. So it's a great way to actually get to KotlinConf, because if you are accepted with a full session, we also cover travel and accommodation, and of course you get a free ticket to go to the conference. So make sure you take a look there, and if you have a subject it would be great for you to submit. Would be really appreciated. How am I? I am great. Thank you so much for stopping by in the chat. Appreciate it. Okay, so with that, it is time for me to introduce my guest for today, who will help me solve day 2 of Advent of Code in Kotlin. Like I said, I'm very, very excited because we have an absolute all-star roster for the entire 12 days of Advent of Code in Kotlin. So today I'm very excited to introduce Michael Zarachinsky, who's the lead language designer for Kotlin. Hi, Michael. Welcome to the show.
Hi, Seb. Hi, everyone.
How are you doing today?
Good, and actually pretty exciting.
That's amazing to hear. Already a little bit in the Advent spirit. I mean, with the music that we have playing, it's kind of hard to not be, right?
Yeah, a little bit. Yeah, I because I used to compete in a few ICPC events, and nowadays I don't compete anymore. But it's this event reminds me of the old days. It's actually fun.
Oh, that's very cool. Well, now I'm even more curious about what your solutions might look like, and whether I can whether I can compete or whether I can compare with a former ICPC competitor. Very very curious. Well, in advance, how do you feel about your solutions? Do you feel like they're good? Do you feel like confident?
No, it's you should have checked a few ICPC solutions beforehand, because usually it's about the speed. It's about some you have to just write the code that works, and that's it. Because you don't have to maintain it. You don't have to. Ideally, you shouldn't even try to debug it, because every time if you start a debugger and things it, you lose 5 to 10 minutes, and it's not the way it should work.
Yeah, I've read a couple of ICPC submissions, and they typically involve a lot of the letter I, the letter J, a lot of array accesses into arrays titled like R. So yeah, I'm hoping we'll see something slightly different here, but even if not, we'll try to decipher it. Okay, well, I'm more excited now than even before. But of course, I also want to invite everybody here to, if you have any questions to the lead language designer of Kotlin, then now might be also a great time to throw those in the chat. And when we have a little bit of time, maybe at the end, maybe in the middle, we'll also make sure to address those, because things are moving a whole lot faster, if I've seen that right, in the recent Kotlin 2.1 release stream, right?
Yeah, exactly, because we had to postpone our work on feature productization and our design work to focus on the K2 release, and now we have more resources and we have better architecture and actually quite a lot of prototypes. So we even created a dedicated page about our keeps, where we can check them on our Kotlin website and see the upcoming proposals.
Very cool, nice. So yeah, I'm already very excited. I also, this is a little behind the scenes look, because they're not out yet, but they'll be coming up in the next couple of I guess days or weeks, depending on what the schedule is going to look like. But I'm personally very excited about the non-local break and continues, which are quite exciting, because it finally feels like Kotlin is really turning those inline lambdas into a first-class language feature. And then, I mean, whens with guards are like one of the big subjects that I think people have been talking about quite a lot. And I would not be surprised if, a couple of tasks down the line, we're gonna see our first good place where a when with guard might become useful.
Yeah, and actually speaking of Kotlin Conf, I hope to see way more talks about language design. But we'll see, because I saw that the number of submissions exceeded the previous year already. So, and we have only 3 days, unfortunately. So maybe we'll have more streams about future language features.
Hey, that would be very exciting. I'm sure people would love to hear more about that. Yeah, people are already very excited about all the new preview features in Kotlin 2.1. So yeah, this is also a little encouragement. Like I typically say, Advent of Code is the perfect time to try something new. So you can, of course, already move on to Kotlin 2.1, even if you haven't upgraded, your production stack yet. It's a great way to take a look at it and look at for example, the new language features that we have here. Also, by the way, hello, Dave, one of the future folks who's also going to be on the stream. Very excited about that. So, okay, great. There's a lot of things already going around in my mind, but in my opinion, now is the perfect time to maybe actually start puzzling just a little bit. I'm gonna reload this page a couple of times and see if I can get the Kotlin sponsorship, the JetBrains sponsorship. It does seem to be RNG, so I'm not getting very lucky, but we'll get there eventually, I'm sure. There we go. Great. Maybe I should read that part out as well at some point, because I have not done that yet. So the reading hat goes on for that extra festive spirit. Here we go. That looks vaguely festive. And like all of these streams, they are presented by Kotlin by JetBrains. Ho ho, hold on to your code. Unwrap coding fun with Advent of Code in Kotlin. Tackle daily puzzles, watch our live streams for tips, and join our merry community. Wishing you happy coding and warm holidays. And we dive right in with Day 2, Red-Nosed Reports. Fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. While the red-nosed reindeer nuclear fusion/fission plant appears to contain no sign of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. They're quick to add that since you're already here, they'd really appreciate your help analyzing some unusual data from the red-nosed reactor. You turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer to help with the unusual data. The unusual data, your puzzle input, consists of many reports, one report per line. Each report is a list of numbers called levels that are separated by spaces. For example, 76421, 12789, and so on. This example data contains 6 reports, each containing 5 levels. The engineers are trying to figure out which reports are safe. The red-nosed reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So, a report only counts as safe if both of the following are true. The levels are either all increasing or all decreasing. And any 2 adjacent levels differ by at least 1 and at most 3. In the example above, the reports can be found safe or unsafe by checking those rules. 76421 is safe because the levels are all decreasing by 1 or 2. 12789 is unsafe because the 27 is an increase of 5. 97621 is unsafe because 62 is a decrease of 4. And then we have the other conditions, like 13245 is unsafe because 13 is increasing, but 32 is decreasing. Or, of course, if we have duplicates like 86441, it's unsafe because 44 is neither an increase nor a decrease. 13679, once again, is safe because all the levels are increasing by 1, 2, or 3. So, in this example, we have 2 reports that are safe. Analyze the unusual data from the engineers. How many reports are safe? All right. Like Benny says, time to suit up for this reactor-themed challenge. Michael, what was your first thinking?
Yeah, like my first thought is I'm really wonder if such a text makes it harder for LLMs to generate code, because for me it definitely does. and I think I skipped the most of part of the text and just straight I took a look at the example and those explanations, which are like very like it's really nice to have them. So it was nice. It was nice reading from you. Like first 2 things that are right here in the text is that I saw that we have to understand whether we have a sequence which is increasing or decreasing, and also we have these 2 adjacent levels, and that they should be not bigger than 3. That's basically my main thoughts. But when I took a look at the example, I understood that we can just forget about constraints, because it's not that the input isn't that large, and we can do everything we want, and just have fun.
Okay, that sounds great. Yeah, it's always a good idea to check the size of the input, or check the size of the numbers that happen to appear here. But this all seems vaguely feasible. Right. So, great. So with this, we are actually going to move over into IntelliJ that I already have open here. The setup that we have is that Michael is connected using Code with me. So you're seeing my screen, but Michael can still move the cursor, make changes, and so on. So let's do a little walk through your code and see if it's good like it is, if we need to make some changes, whatever might happen.
Yeah, so I just used one of the templates that we provided. It's a template with Ampere. So basically I have this main function and a few local ones, which is quite nice so that they don't escape the scope. And speaking of the first, I have this input. It just read lines. You can see that it just takes some file and just returns like list of strings. Quite easy. And then it's probably one of the hardest things when you work with strings, with raw strings. You have to use like the right delimiters and split functions. So the first thing we do is that we translate it into a more convenient container. So in order not to use strings, but to use numbers. And here, this is where it's nice in Kotlin. Just we use like a small piece of this declarative or functional thing. But as we'll see, the rest of the code is just heavily imperative code. And it's nice because we just can combine functional stuff with imperative stuff, with procedural stuff, and so on. And because it's not a philosophy in Kotlin to be functional, but it's just one of the tools that we can use and use it when it's just really convenient. Yeah, so we just now have a list of numbers, and we just check whether it's actually not a line save, but because I didn't read the the text carefully, so it's a report save. So it's a report save, and just increase the result and return the result. And how do we check that our report is safe? So we have to check 2 options. First is whether it's increasing or decreasing, and if it's safe in terms of adjacent levels. So we go from 0 to last index -1. And here we just used one of the features that we introduced in Kotlin 1.9, which is range until operator. And we actually don't see here any body of the function because it's an intrinsic function because it's located in int class, which doesn't exist as a class file on JVM. So it's actually the compiler which provides the implementation of this function, but it's actually very easy. If you just want to implement it ourselves, it's something like actually, for example, int range equals this until other. So something like that. I have. So yeah, it's a quite straightforward function in order not to use last index -1. So what we do next is that we just take number of I, then the next number, and check whether if the adjacent levels are correct or not. And then we are checking whether our sequence is increasing or not, because we think that initially it's all increasing or decreasing, and if we see that just two elements are just one less than another, then it's definitely not decreasing, and vice versa. And if A equals to B, then we just are saying that it's neither decreasing nor increasing. And so the result is pretty straightforward. Again, it's just we check that our sequence is either increasing or decreasing, and it's safe in terms of adjacent levels. And that's basically that's the code that I tend to write if I have to solve a task like this one, because it's just imperative code. It's very simple. And it's easier to play with it, to extract some things, check the conditions. It might not be the best code in terms of verbosity, or it's not that functional, but we'll see the functional style a bit later. Yeah, but it's still, I think it's a pretty understandable piece of code, and yeah, easy to use. Yeah, I think that's mostly it about the first part. And in terms of memory and CPU, it's just a simple linear solution. Yeah, nothing really to comment about this.
Okay. This is interesting, because I mean, if you're in chat, let me know how you feel about the solution. But I feel like you're kind of maybe deliberately going a little bit against the grain of what a lot of people expect when they think about oh, I'm gonna build this in idiomatic Kotlin, right? Because a lot of times we're thinking about using the standard library to its maximum, seeing if we can chain a bunch of functions together. Maybe just for good measure, we throw in a let or an apply or a with. But that's not the case here for you.
Yeah, exactly. And that's what I like actually about Kotlin, because there is no real philosophy behind. There's just a lot of tools that you can use. And for example, it's very convenient to use mutability here. It's a nice thing, because in many languages, in many approaches, you can hear that mutability is something that's really, really bad, and we have to avoid it as much as possible. But actually, it's really nice. And in many applications, we want mutable data. We want to quickly change it. It's how our world operates in many cases. And if the task is relatively simple, then I don't see any need to use any I don't know, really niche functions or maybe niche approaches to solve it.
Yeah,
but,
and go ahead.
I can show the functional approach if you want, just to compare it.
I want to see that in a second, but just briefly, I think one of the other good parts that we're seeing here is that while you're using mutability, right? You're using vars, regardless of this, it's all still constrained inside like a function, right? So even if you're using mutability as part of a function body, you're not running the risk of like having that mutability escape out somewhere and then all of a sudden having a very hard time trying to track who's making a change to what object, who has what state, or multiple people trying to access the same thing, and instead we really kind of constrain it here.
Yeah, you are completely right. So it's the key is to use fine-grained mutability. It's when it's local, then it's absolutely fine. But usually the problems when you want to share mutable state with someone or something, then it becomes a problem, and we need language support with and compiler support and so on.
All right. So let me just very briefly take a look at the chat here for a second. I'm seeing a lot of people mention zip with next, so that's going to be maybe quite exciting. Let's see what else we might have. Some folks say that part 1 was also imperative. Like Maya says her part was imperative because she only wanted to loop through once rather than maybe run multiple loops. We'll see. Windowed is coming up here. Some people mentioned, Herbert mentions it's not quite obvious, but I think maybe this is actually a comment about your code. It's not very obvious that at first glance that the constraint is covered that any two adjacent levels differ by at least one.
Yeah, that's true, because that's actually a part of the check where when we have two levels to the same two levels, it means that our sequence is neither increasing nor decreasing. So it's actually checked here. So the statement is going to be false if we have, for example, 3 and 3, two adjacent levels. So that's what I decided, not to put it here and do it as a part of a separate check. So maybe if it was a bit more complicated, I would put it in a separate check. But that's a valid point.
Okay. I do have to say, by the way, I think this one kind of almost went by the wayside here. I really like the fact that you ended up using dot absolute value as an extension function, which I think reads a lot nicer than what I did just yesterday, which is like calling abs off something.
Oh, okay.
Like I feel like this is a very natural way of doing it. Okay, so people are saying they solved it with window, zip with next. Let's see what you came up with from the functional side then, and maybe we can compare a little bit also with what I wrote.
Zip next is our friend here, and so we have this function zip with next, which just takes it's way easier to take a look at the implementation, and it's again one cool thing to explore standard library is just to navigate to its and see the implementation. Usually, if it's not that hard, it's easier to read it through. So basically, it takes first element, it takes next element, and invokes transform function and adds to the result. So if we go back to our function, we'll take our first element, next element, and just take the difference. So then we have to check, first of all, is that our adjacent levels are just in the range of from -3 to 3, and check that our sequence is just decreasing or just increasing by invoking, by going through this sequence 2 more times. And it's pretty nice because if we compare to the previous solution, it's a bit better in terms of that I didn't have to use ranges, because it's usually a sort of box. And for example, if we take a look at this loop, we can see this this range, and we know that it's a source of bugs like +1, -1, which range to use, and so on. And actually, I made a mistake in the second part, specifically about this, because I just copy-pasted the implementation and I forgot that I didn't have to use -1 there. Yeah, but otherwise, it's this implementation. It's if we compare it in terms of memory without any benchmarking, just looking at the code, that it creates actually more lists. We have to traverse the list actually here 3 times instead of once. Actually 4 times, and also create a list 1 more time. But it's normal. It's not a problem because it's so-called young generation and for garbage collector, and and it's quite local to our function. So all lists will be eliminated. But still, if the constraints were slightly different, it could have been a problem. But otherwise, it's a pretty okay solution. However, I still prefer the imperative one. I think it's it's still easier to debug if you want to go through the checks one by one.
I find that very interesting. First of all, on the topic of complexity or performance here, it's probably the one thing that I remember the best from my theoretical informatics class, and the argument that I always apply in scenarios like this is that the complexity class of O of 4n, so going through the list 4 times, and O of n are the same complexity class.
Right.
So that's typically my excuse for not optimizing out the second loop. The square is harder to argue against.
Exactly, but it's in reality it actually it depends. So if we have 1 billion operations and if we have 4 billion operations, it's quite a difference, let's say that. And so sometimes we have to optimize this constant as well. Not in this case. In this case, I think you can just write any code you want and have fun.
Of course.
Yeah.
So let's actually briefly compare this and see what I wrote. Just briefly here, I have my day 2. Actually, we can look at, first of all, once again, we can look at the spaghetti that I originally created, which is always great fun. Which is this lines count. So I'll just read the lines and then I'll check whether all of them are safe. I use an extension function for this, and for part 1, the function is just called isSafe. I realized that I didn't actually turn my individual elements into the individual numbers, so I do the split, and then I also just do the toInt, nothing special here, and then I just extracted an extra function which is called isListSafe. And here, I also use the zip with next function, like a lot of people have mentioned. Maybe just looking at this might throw you for a loop. Like, why am I just calling zip with next without any like parameters passed or like receivers? But that's because isListSafe in my case here happens to be an extension function on list of int. So this is the same as writing this .zip with next. I didn't do any arguments here. I could have, of course, provided a lambda directly to make some kind of transformation. But here I was just like, okay, I need those pairs and I need them somehow. Like I always need pairs. And when I'm thinking, in my mind, I always go, I want to write windowed to, and then I remember that there is zip with next, which is slightly nicer because rather than having window 2, which whose type is, if my type analysis might show me, it would give me a list of lists. Here I get a list of pairs, which I can then destructure quite nicely again. Then I just check whether all of them are increasing, which is just we'll take a look at the second and subtract the first, and if that's within the range of 1 through 3, and that happens to be the case for all pairs, then we're all increasing, and for decreasing it's the same. Here I just have an intermediate, some debug code remaining that probably shouldn't be here, so I can just inline this property, which might be slightly nicer. And of course, there's still things that can be like obviously refactored here, but like this gets me there, and it's also a linear solution. And then, like someone in the chat already said so nicely, I spent not the whole day, but I spent a little bit of time trying to refactor this. But I mean, I have the unique opportunity of maybe having the lead language designer review my code here. So do you see anything obvious that could maybe be done a little bit nicer here?
Well, actually, I forgot that we can use zip with next without arguments. So when my first thought was, wait, what's going on here? Is it some custom implementation or? And plus, I don't know, but maybe it's me. But I wouldn't use extension functions on a list because it's not. Maybe it's not that clear that when you invoke zip with next that it's actually an invocation on a list of ints. So I would maybe pass it just a regular parameter, yeah. Because in this way you have also a name which carries the actual information and about the data. It's not just a list of ints, but it's actual levels, and now it's a bit more clear what we are doing here and what is the actual semantics. Yeah, for example, like that. Then we have all increasing. Yeah, then I also there's probably a question not only for me that about the priority levels of our operators, because it might. Because I have a question, because is it like pair first in 1 to 3, or it's pair dot second minus pair dot first in the so it's also I would ask to put a parenthesis there just to make it a bit more clear, and maybe it's worth having an inspection in IDE. Now it's interesting.
I think this is just
yeah.
Is my analysis just broken, maybe? I think it might be, because I think this should be okay.
Yeah, it should be okay, definitely.
Okay. Well, I think there's too many moving parts here. Let me close that file and open it again. Okay. Well, we'll eat it for now. What are anything else?
Probably no. We could just. But I'm actually surprised that it's possible to write it in some different way as usual.
Yeah.
Yeah.
One of the parts that I still had that I just didn't think of in the like in the heat of the moment, but like 2 minutes like after submitting, I was like, I mean, these are pairs, so we can like destructure these, right? Like we can actually write these as like a B, which makes this like B minus A, which is like a little nicer, and then the same thing like down here, A B, and then B minus A, and then I mean we can just run this, and that's hopefully going to. Yeah, there we go. That looks a little better. There we go. Yeah, so this also works, and it gives us the same thing. Let's see what I actually like, how my final refactored version of this looked, because I don't actually quite remember. First of all, I gave things more names. I did read the text, and I was like, okay, these are reports, so I can actually grab each line, I can split them, and I can immediately turn them to integers. And then for part 1, we just check whether the reports are safe. Yeah, and this is pretty much the same, except like we said, I am applying the suggestion here. That's kind of this version, and moving the receiver to parameter. By the way, this is one of my favorite inspections. Maybe if you out there find yourself in the same situation, you might not know this. You can always convert a receiver to a parameter, which in this case would be levels. But you can also go the other way. So you can also hit Alt-Enter on just a regular parameter and turn it back into a receiver. So that goes in both directions, which is very nice.
Nice.
I mean, okay, cool. So this is pretty straightforward. Noah's wonders if you could fold and propagate to Booleans so that all are increasing and all are decreasing get computed in one pass. I would assume yes. I would also assume that would not make your code a lot nicer. Those are the moments where I'd probably introduce a data class for like state that I would want to drag along with me, and then you probably know that you're already in the weeds if you have your structures there. Okay, cool. But we've seen there's two ways of solving this. It's not too bad. There's multiple ways of solving this. All of them are slightly different. So with that, I think we can just move on and see whether advent of code, whether the reactor throws us for a loop, whether maybe we've coded ourselves into a corner, whether we made some good assumptions or some bad assumptions that allow us to reuse or not reuse things. We'll find out in part 2. The engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor's safety systems tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now, the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. More of the above examples reports are now safe. The first one, 76421, was already safe without removing any level. 1, 2, 7, 8, and 9 is unsafe regardless of which level is removed. So if we took out any of the numbers here, it would not turn it into a safe sequence. 97621 is the same because it's unsafe regardless of which level is removed. 13241 is safe by removing the second level 3, which would make it 1, 2, 4, 5, which is ever increasing and only by 1 through 3 in each step. 86441 is safe by removing the third level 4, because once again, now we got a decreasing of 8 to 6 to 4 to 1. And 13679 is safe without removing any level because it already was. Thanks to the problem dampener, 4 reports are actually safe. And like Maya says, I think sometimes we might want to have a problem dampener for our flaky UI tests. That would certainly be useful. So we need to update our analysis by handling situations where the problem dampener can remove a single level from unsafe reports. How many reports are now safe? Okay. Michael, thoughts?
Yeah, I immediately, my first thought is that it's the same problem. So basically the same. It's really nice, like in terms of mathematics, because you've already solved the first part, and here you have to do the same. Just remove the element. And again, because I also thought that maybe we have to write a bunch of ifs to make it work. But again, looking at the number of columns that we have, maybe 6 or 8 columns, it's just not worth it. Because you've probably seen that diagram when it's you can optimize your code to the point when it becomes non-maintainable at all.
Mm-hmm.
So I decided to take the easy way and just use our mutable lists and create one more loop and call it a day.
Okay, I actually when I first started this problem, I thought I was onto something clever, but then it did turn out that what I was onto wasn't quite as nice, because I figured maybe I can just walk through and maybe like keep a flag or something of whether this was turned into an invalid or whether like we exceeded our grace period. But as it turns out very quickly, because we have 2 constraints, we have the constraint of like constantly going up or down and being in a specific limit, this grace period thing doesn't really work, because sometimes you might just, if the second element is the one that you might have to remove, you might just guess the wrong direction, and you might just like land yourself nowhere. So very quickly, I also defaulted back to a version that was brute force.
And so actually, I think it shows that the problem is quite nice, because it touches something inside you that you feel that something is wrong, and you want to write a clean and very fast code. So it also means that you're a good programmer, because you want to make it as fast as possible. But sometimes it's just easier to, I think, to write not very clever code, but maintainable one.
I think that's a big life lesson. And again, this is the beauty about Advent of Code, is that you kind of set your own goals. As long as you get the stars, it doesn't really matter whether you go for clean or fast, or like least memory usage, or built in Microsoft Excel. So okay, let's see your solution.
Yeah, so we are going to reuse our original function to check whether a report is safe or not, and do just one more for loop, inner for loop. So we have our input. Again, we split it into numbers. And then this is where I made my mistake and didn't get the submission from the first attempt, because I just copy-pasted my for loop and wrote here this less bracket. And so what we are doing, we just going through a line. We are removing a number by number and checking whether this line is safe, and that's it. Because we know that if we remove, for example, the first element or the last element from a safe line, then it's going to be safe. So we are counting on that. And we check that if we remove, for example, some element from it and it's going to be safe, then the whole line is safe, and we are adding it to the result. And that's basically it. So I think that the most interesting part here is how you work with collections. And here we use our generic approach with apply function, which is actually our way for builders. If you want to build a collection, it's always easy to start typing with something mutable, for example, map of into string, and then apply, and then put some elements and so on. And then if you want to just actually, not this, but this collection, and give it a read-only interface that it's actually just a map of strings. And here it's the same. I just take the whole line, I turn it into a mutable list, and remove an element with the apply function. And that's it. And that's the solution, which is quite straightforward. And again, it's I also tried to write a few ifs, but I understood that I'll have to debug them for, I don't know, half an hour to make it work, but it's just, it's not worth it.
Yeah. So I'll be honest with you. I like this solution. It gets us exactly to where we need to be. We've done a thorough analysis of like our input data and its size, and we can we're reasonably sure that this is going to work in with the right runtime performance for our inputs, and it's pretty easily readable.
Yeah, and if we take a look at the functional version, it's not completely functional, because I use this count function, and then I just go through indices, which is another helpful extension when you work with collection. And here, again, because Kotlin is not completely functional, I still can use my mutability and quickly change collection and invoke our original function to check whether it works or not. So a good thing is that I didn't have to refactor my code, and I just, again, because we solved the first part, and we can reuse the main part of it in the second part. So yeah,
Yeah. If we, I can quickly again. This is quite nice. My solution is quite similar, but it's still slightly different. Because so originally I also had something like what we have commented out here, but essentially at the end, I just decided to do the following. I just created I used filter indexed rather than just creating a mutable map, which now that I think about it is probably the worst solution, because this does look at all the elements rather than just like jumping to a specific index and removing it. I don't know what the overhead comparably is for converting it to a map. Given that these lists are typically like 6 elements long or like 10 elements long. And I have learned yesterday from Seva that it's not so great to guess about these things, and that we would have to write a benchmark, but we're not gonna go through that. But from there, we essentially just call is report safe again. So once again, we just have a slightly changed input, and then we just check we also reuse the same function. Yeah,
good.
But this is actually something that's quite interesting for me to also introspect a little bit, because I very much I feel like there's this blog post from Roman Elizarov, which is called "Immutability We Can Afford," and I think a lot of Kotlin developers have also read this, which I think the part that always kind of keeps sticking to people is like, okay, it's all right to be immutable, which for a lot of people also means like we should always strive for like a maximum immutability. Which kind of led me to have this slightly allergic reaction to call just two mutable lists and then quickly applying something. But again, I think it ties in quite nicely with your first solution again, which had a whole bunch of mutability, but it's all constrained within a function. Like it just uses what the language gives you in a safe manner, in a constrained manner that makes you be able to write the code you really want to.
Yeah, exactly. And I think in many ways, mutability, it's mostly about mental model. So, for example, immutability is great for caching when you want to share with someone and just be sure. You want to use immutability not because of mutability because of some performance reasons, but because it's just easier to reason about your code and not worry and then debug some subtle issues. And because your memory is now in consistent state. So immutability and mutability is really nice for just for the whole consistency and mental model. And if you want to be performant, then it's there are techniques and we really have to benchmark our code. And also speaking of collections, so here we use lists, which is like really nice. But I think that 10 years or just a few years ago, we would use arrays because it was just this thing that lists it's a heavyweight object and we box our ints here and there. So and we have to use arrays, and that's actually was the way to program and to solve most of those issues. And even, for example, if you take a look at the Eclipse compiler, at some point they decided to rewrite it completely to arrays, which I think it's harder to maintain when your compiler works with arrays and not with lists and all those convenient methods.
So I'm gonna do something to you here, and I apologize in advance,
okay.
because it's not your tweet, but there is a tweet that is semi-famous from Roman Elizarov, which is Arrays are one of the most shameful areas of the Kotlin language. There's not much we can do about it due to the JVM interoperability needs. Don't use arrays in Kotlin unless you understand what you're doing and have some very specific low-level needs. Prefer using collection types. This is one of the reasons this is one of the tweets. It's from 2020 that I keep on digging up when I see an array being used in someone's code without good justification or without an obvious justification. But I am very curious, now as the lead language designer, do you have thoughts on this? Would you like to expand on this?
Actually,
has it changed?
Yeah, it hasn't changed, and we actually would love to move to collections and to more collections. For example, we still use arrays for some reason. Well, for a pretty known reason for var args. So whenever we write a var arg, we create an array under the hood and then work with array, and we have to deal with the fact that on JVM they are reified, and we have to deal with those copy functions and checks and so on and so forth. And it'd be easier, and sometimes actually it might be even more performant to use collections, because there we can use the whole API and be sure about the state in those collections. So yeah, I think that it still stands. If you want to work with collections, just use lists. But if you really want to work with low-level stuff, then arrays might be your way to do so. But there's no need to do so. Unfortunately, there's arrays might become quite popular, I think, in a few years if Project Valhalla lands, because there's going to be this Project Valhalla in the JVM ecosystem. It's about bringing value types or more primitive types to the JVM. And the problem is that they are going to behave the same way primitive types work today, and which means that we are going to have boxing inside our lists, and arrays are going to be fine. So I think that it means that a lot of people will start working with arrays to avoid this boxing with value types. But I hope I might be wrong here, but that might be the case.
Interesting. It sounds like there's gonna be some challenges waiting to be overcome in the future there as well. Then.
Yeah, exactly. Yeah, unfortunately, there is nothing about reified generics that we are waiting for in JVM. So arrays are going to be a bit more popular than they were before.
That's a really cool and interesting prediction of how that is going to change things. So I guess we'll see, and this is quite. I'm always quite curious to where these things are going. Mm-hmm. I do see a couple of people discussing, by the way, around the complexity and the of course the big O notation, the fact that we are, very, very obviously using a quadratic solution for our implementation. Again, this is one of the questions of is fastest execution time the most important to you? If this is something that you do enjoy discussing, I do invite you to join our Kotlin Lang Slack. If you go to slack-chats.kotlinlang.org, and I'm also going to put that in the chat over here, there's a button called Join Slack, and here you can get yourself an invitation. There's about 50,000 people, or I think more than that already, and we have an Advent of Code channel in here where you can discuss all kinds of things, and there's typically a thread with the Advent of Code solutions, so the spoilers one and the no spoilers one, if you want to have some help, and you can click on that and you can find some solutions that might have a much better runtime performance than what we do. and you might be able to pick up like a trick or two about whether that's windowed or some other standard library function like unzip even before you join for our daily streams. So make sure you take a look inside there. There's a whole lot of discussions going on there that hopefully also spark the joy of Kotlin and advent of code there. Okay, great. Well, Michael, it's been really, really awesome having you on the show. This was great. I do have one final question. In writing those solutions, which it's not necessarily representative, but when you wrote those solutions, did you at any point go like, I wish we had a better way to write this in Kotlin? I wish there was a way where I could express this slightly easier or slightly nicer, or why do I have to do it this way? Like we gotta have a meeting about this sometime soon. Anything like that?
Yeah. Actually, two minor things. The first thing was about ranges, because I made this stupid mistake because I just I forgot because I copy pasted and actually I did not see it clear that there's a -1 in ranges. So my first thought that we probably should have, instead of dot, we should have dot equals dot less and so on. So that's actually
I've been a proponent of this for years, very much so.
And the second thing was it was about, if you can open my first part.
I will just follow you again. Here we go.
Yeah, just a sec. Yeah, so here I use this save and save equals save and end, and of course I just wanted to write this and just but it's not possible because and then is not an operator in Kotlin, and it's done for a reason, because we believe it's important to keep them only for booleans and not to extend them and because we know that it can be quite messy if this operator is going to become an operator, actual operator extensible. But that's what I wanted to initially write when I was writing this code. Otherwise, I think it worked pretty well for me. Because usually when I work with strings, I file a few issues, because my favorite one is that if you have a character, for example, and in Kotlin it's not possible to, so that should be a mistake, because I compare it with string, because I have to use here, and I remember filing like an IDE quick fix a few years ago, and it was fixed by our contributor from Japan. We even sent him a T-shirt because he fixed a lot of issues like these ones.
Okay, no, that's it's advent of code is doing some good here as well, and I have to very much echo your perspective on the dot and dot less than operators, because sometimes in my free time I write a little bit of Rust code, and in Rust it happens to be that the dot operator is end exclusive.
Exactly.
And they have a dot equals operator for end inclusive. And those, that costs you a pretty afternoon every once in a while when you're like literally just reading the wrong thing and wondering why things are going on. So I remain hopeful that maybe in the advent of code 2025 we'll who knows how quickly, but maybe we'll see something like that. Would be quite exciting. Okay, I think that's an absolutely amazing way to wrap things up today. But of course, if you folks are still interested in doing more, first of all, make sure you solve the challenges yourself before you tune in again tomorrow and the days after, because we do have our campaign that's been going on. We have the live streams. We have 7 leaderboards that you can join. If you join those, even if you aren't going for the gold, even if you aren't going for the quickest solution, you still have the ability of getting some of the exclusive prizes that we have prepared for Advent of Code 2024 just by being in the leaderboards. And in addition to this, if you solve your tasks and you tag them using the AOC 2024 in Kotlin topic on GitHub, like my behind the scenes repository already has, I hope. I thought I already did it, but I guess I didn't. So this is AOC-2024 in Kotlin. Oh, this is my 2023 one, but I'll still briefly do this anyway. We can see that we already have 590 repositories, which is exciting because just yesterday, I think we were still sub 400. We were at like 300, 380 or something like this. So if you tag it like this, you are also entered into a prize pool where you have the chance of winning some things, as long as we can contact you somehow. So make sure you have some information, some contact information on your GitHub profile. If you're not super sure where to start, we also have a template, the Advent of Code in Kotlin template, and we actually have 2 of those. We have one that's the classic one based on Gradle, but like we saw on yesterday's stream, if you missed that one, check it out. We went on so many tangents, we did benchmarking and whatever, and we also did some stuff with Amper, which is the build system that a whole bunch of people at JetBrains are currently working on, and that makes things very, very nice. I mean, look at that build file. It's like 4 lines in total, which is quite enjoyable. So check out all of those things. And of course, we do hope that you will tune in again tomorrow in the same channel. If you want to make sure that you don't miss any of these streams, make sure you head on over to our streams page and hit notify me so you'll get a quick notification. And then you can join us for all these wonderful streams, even the ones where the designer maybe forgot to give me like a Christmas ornament. And so now I'm just holding a weird nothingness. Okay, great. So I look forward to seeing all of you tomorrow, where I'll have another amazing guest, and I think we'll have a great time doing another puzzle. So, Michael, thank you again so much for coming on today. Really appreciate it. And thank you to everybody who decided to tune in today. I'll see all of you tomorrow. I'm going to have some dinner and finish my New York style tea. So, have a great one. Take care. Bye-bye.